Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode we're going to take a closer look at cloud computing. So let's dive right into it. Now first thing you have to understand, what is the idea. Idea is very simple. You are using server for computation. Generally we use servers for data storage, basically it stores your emails and all that, but here we're going to use it for processing also. And on top of that, this also allows us the idea that we can use anything for any task. Basically your mobile phone can do your accounting, so can your laptop, so can your tablet. This is the idea for it. Now of course this assumes you have good quality internet infrastructure. That will become more clear as I discuss more about this. So how the heck this magical thing works? Think of it this way. You first need a computer, obviously, undeniably so, and then you need supported app. Which apps? Basically almost every app is supported in this scenario. Then the weakest point comes along, that is internet service provider. Now if they decided, you can have a very good experience versus very bad experience. And after that, the last step, that is remote end and server processor. Now you can even access supercomputer if you have the money for it, and many supercomputers are plugged into the cloud, and they are used for number crunching, data processing and weather analysis. So there are many things. Even a full-fledged supercomputer can be accessed through cloud. Anything that is connected to a internet, it's quote unquote in cloud. So this idea of cloud is something different. It's nothing new. We know how to do this. We have been using it since the beginning of internet, so nothing fancy or new about it. However, the biggest hurdle was in the early days, as in from 1990s to early 2010, was internet service provider. Now from 2010 to 2020, all over the planet we are getting optical infrastructure. Slowly but surely, almost every place is getting optical infrastructure. Now if you are familiar with the idea of internet, you must know internet always used to work on optical. Then what's the new thing here? Optical was undersea cables, but the moment they terminated, basically where they come on shore, they go through multiple processes, and each of those processes introduced what we call lag. Basically each of those processes took few nanoseconds to few milliseconds. So even though they are taking the low impulse, basically a very low power light pulse that is coming, they are taking it up, converting in electrical signal, boosting that electrical signal, then emitting it against as a laser diode. Now you can understand, even though that process can be refined and fine-tuned, there still would be a physical lag to it. So even though like your whole optical fiber, that is 1000 kilometer, will have few nanoseconds of lag to few milliseconds, this whole block alone will have 20 milliseconds of lag. This one block where optical goes in, optical comes out, only that thing that it has been boosted. So this whole idea was the limiting factor. That's why I'm saying this idea is not new, and you can see even Linux, Android, Windows, everything is compatible by default, but ISPs were the bottleneck, and supercomputers, they were always used like that. Many researchers work around the world, because you can have some engineers from let's say India, some scientists from Africa, some let's say analyst from China, things of that nature. You can have all around the planet people working on one supercomputer. So this how does it work? It's super easy. It's just anything that is connected to a computer. Bottleneck being internet service provider. So then comes the idea, okay, if it's this old, what can we do on it? Like what you and I can do on it? Simplest answer is almost everything. Almost. Now basically if you are familiar with Google apps, you must be familiar with Gmail, you must be familiar with Google Calendar, you must be familiar with Google Documents. So you can understand, like these things, this application that is available for free, there are people whose job depend on this kind of software. Basically there are people who are getting paid just to maintain Excel sheet. There are people who are getting paid just to take care of emails and like office emails and things of that. All of those for free of charge, additional charge after internet service provider is accessible to you. So this sort of scenario is very encouraging. You can do almost anything, and these things that I'm specifying against of you is like email and accounting. These are low ping scenario. Basically you don't need a response here. Best you're gonna do is type some numbers and all that, so it doesn't need very good latency. It can be worked on very bad latency. So this is the first thing that was automated. That's why these services are for free. You can use it anywhere. Now then we'll come to the big chunks. Big chunks are 3D rendering and video editing. Now you're like, whoa. 3D rendering, yes. If you are working in the 3D industry, you must be familiar with the concept we call render farms. Basically, the idea is you make 3D whatever you need to make, then you send it to this farm to render it out. This is how it's always has been. That's why even almost all Adobe, pardon me, not Adobe, as in Autodesk, 3ds Max or Maya comes with what classified as back burner. In that back burner there is a feature where you can send your data for rendering and it will be rendering the farm or in cloud. So, and you might be like, okay, how the heck video editing works? For simplest example, I could ask you to see how Linus Tech Tips does it, because video editing, your YouTube also allows you to do video editing, but it's a very low end kind of thing. But if you want to do 4K or 8K video editing on the cloud, we can only do it in local network right now. There are some places which has like, very high bandwidth, low latency optical connection, they can do it, but almost everywhere else you cannot do it practically. So I would urge you to watch that Linus video where they show how they're using a server and having that server doing the number crunching, basically doing the heavy lifting, so video editors can work with much more efficiency. So use cases wise, do not think about anything. All you are doing is taking your input and output and stretching it out. That's all you are doing. Basically, you are taking your CPU or computer box that you have and putting it wherever it is, and just having a data input and output. So computer on your end just becomes that input and output management. So if it's this amazing, are there any problem with that? First and biggest problem is bandwidth and latency. Now bandwidth, think of it this way, how thick your pipe is. Basically, the thicker the pipe, the more bandwidth you get. Generally rated in megabyte per second. To give you a context, your hard drive generally works at more than 100 Mbps. And this is capital B, not small b, so it is 8 times than that. So very, very thorough amount of bandwidth is needed for this. Like if you want to automate everything or cloudify everything, you must exceed that. Then you come to like how about doing heavy applications where you have CAD designing and high-end 3D modeling, not rendering, modeling. You have to exceed the bandwidth of your RAM, which is few terabytes per second. So that bandwidth limits how much application you can do that. Okay, let's say you do something that normal mechanical hard drive can take care of. Your internet connection is wide enough, bandwidth is high enough that you can do that. Okay, awesome. Then the second factor comes in, which is the biggest problem, which is what we classify as latency. How long does it take from your computer to send an impulse? Okay, like move left. Let's say you push the command move left, and it's like, okay, the signal is coming from your computer, then it's gonna go. How long does it take to reach the server? Now that latency I already specified. In earlier days, we had no technology to properly boost photon signals into photon signals. We took the photon signal, converted into electrical signal, boosted it up, then had that system going on the other end as a photon. Now again, I told you, like your whole fiber cable will barely introduce 1 millisecond. This converter station alone will introduce 20 milliseconds of latency. But as you can see, this is the whole infrastructure of undersea internet cable. Basically, where is internet? These cables are the internet. Of course, these are not the servers, but these cable throughputs are generally in few petabytes per second. So, and they connect to the server homes and to internet service provider. So as you can see, India has a lot of them, China also has a lot of them, and there is a very thick trunk cable system going from America to Europe. So these cables are the fastest lane possible. However, the recent advancement in crystal technology allows us to have photon amplifiers. Basically, photons comes in, light pulse, and it gets amplified without changing state. Basically, your light is still moving at light speed. This is what allowed cloud computing to become more powerful, more capable. Because without it, we always had bandwidth. Bandwidth was never an issue. Latency was. Now you can, as you can see, these puppies are very high bandwidth. They can, handle a country's infrastructure like this. So latency was improved once we had photon to photon. Now you might be familiar with nowadays almost every big city has optical connection where you can get it or direct optical connection that comes to your home. Not to your business or a big client, to your home. You can get it. In India, Jio allowed us to have that. So from today onwards, you can actually live in a city in India where you have optical system where photons basically travel at light speed till the server. So your latency is reduced to very, very tiny margin, because as you know, light travels at 3 lakh kilometers per second. So once you reach that, then only you can do high-end basically CAD modeling or 3D modeling of that nature on remote end. Now only thing after this is that right now our infrastructure is not built for this. We have the bandwidth. Basically, first thing when internet came along, everybody was going for bandwidth. So we got a lot of bandwidth, but our infrastructure is not built in such a way that you can have high quality in terms of a ping. Our ping would be very long. And if you are thinking about wireless computing, no, just flat out no, it's never gonna work, because you are changing it, and you are changing your photons into basically electromagnetic radiation, generally microwave. So that alone itself takes basically a lot of milliseconds. On top of that, that signal has to travel to you and come back, while it has to be calibrated for the distance. So there is a lot of latency. So can you do cloud computing, low level cloud computing as in management, accounting? Obviously. But 3D video editing and things of that nature, no, you can't do that. So if you're thinking about this sort of structure, yeah, that's never gonna work out. But from your home computer, you can do this. Now, even if, let's say we figured these things out, the final problem would be, it's not cost effective yet. Like I told you, like as many, like India used to have one optical fiber cable. Now it has multiple. And as you can see, like this cable used to be in 1990s, there were barely 10. Now there are 100. So more cables equals more, bandwidth. So once the cost goes down low enough, then only this will become cost effective, because I told you the bottleneck is basically your internet service provider. However, on top of that, let's say you fix that. Let's say your government is like, okay, we're gonna collect income tax and we're gonna spend some amount of money, so everybody gets internet. Awesome, no problem. After that, whoever is running that server also needs money, right? They must make profit, otherwise they wouldn't do it. So that's the final nail, that economic aspect. It's very practical if you can afford to pay for something. Like let's say if you are familiar with 3D movie or Michael Bay movie, basically they take upwards of 220 hours to render one frame. So you can understand, to have people waiting that long, which is like upwards of weeks for one frame, is just not economical. You can't have artists. Your whole cinema will take freaking 8 to 9 years to render out. So they farm it. The signal would be built here, then it will be farmed out here, then it will be farmed to some China's farm, then farms to some Brazil places. So that way they can distribute load. So for them, cost is not an issue. It's a multi-million-dollar project. But for you and I, that video rendering cannot be a thing on cheap. You can do it today also, but it's not cheap. So let's say for me, once I have done this video and I have to render it, like once I have done minor things to it, that rendering takes, let's say, 40 to 50 minutes on my computer. Now let's say in a render farm that I can afford, it may take, let's say, 5 minutes to do that. Will I do it? No. Why? Because it will take me freaking 40 minutes to upload, then 30 minutes to download, because of course the file will become smaller after the rendering is done. So you can see, like, I will be back to the square one. So right now it's not very cost effective for everything. So this was my presentation on cloud computing. I hope you liked it or learned from it. In that case, please leave a like. If you didn't, don't worry about it, you can dislike it. I would urge you to leave a comment, as I reply to all of them, and please subscribe, press the bell icon if you're free, and as always, thanks for watching.